So discrete or continuous? That's going to be our question as we go through several of these problems. So here's a first problem. You are in charge of reserving hotel rooms for a youth soccer team. Each room costs $69 plus $6 tax per night. You need each room for 2 nights. You need 10 to 16 rooms. We are going to write a function for the total hotel cost, and then we're going to graph it on this grid that's available for us. So first of all, let's define some variables. So first of all, what is the independent variable? Our independent variable is down on the x-axis, and it's the number of rooms. The number of rooms dictates the total hotel cost. The total hotel cost over here is the dependent variable. So we are going to let R represent our number of rooms. The number of rooms we need is R. We will let H be the hotel cost. So those are our two variables. Those are the ones we're going to plug into our function. So let's go back. Let's read the given information one more time and make a determination of how much each room costs per night and then for 2 nights. So each room costs $69 plus $6 tax per night. So that is $75 for 1 night. But we need each room for 2 nights. So let's go ahead and double that $75, and we find that it cost $150 per 2 nights. And that's how long we need the room. We don't just need it for 1 night, we need it for 2. So we need to use that. So now let's write this function. So H is our hotel cost, which is our dependent variable, and R is our number of rooms. So our hotel cost equals $150 times the number of rooms that we need. This is our function. Now let's graph it. So first of all, is this discrete or is this continuous? So let's think about this. Can we rent a half of a hotel room or a quarter of a hotel room? No, we're not going to do that. Either you rent the hotel room or you don't. So this is most definitely a discrete function. So here goes. We'll make a little table of values and then we can plot the points. So R is our number of rooms, H is our cost. Obviously, if we get 0 rooms, the hotel cost is 0. So 0, 0. We get 0 rooms, it costs $0. If we get 2 rooms, 2 times 150 is 300. If we get 2 rooms, it costs 300. If we get 4 rooms, it costs 600. So this should enable us to extrapolate. That's a good mathematical vocab word for you. We're going to extrapolate here, extrapolate, that this is going up by $300 every single time. So we can just follow that trend on the graph and we can see how much the hotel rooms are going to cost us. So if we get 10 rooms, it's going to cost $1,500 for the 2 nights. If we get 12 rooms, it will cost us $2,100 for the 2 nights. If we get 18 rooms, it will cost us $2,700 for the 2 nights. So once again, this is a discrete graph. Do we connect those dots? No, we do not. Because once again, we're not getting a half a room or a third of a room. We're either getting a room or we are not. That is a discrete function. Next, a 20-gallon bathtub is draining at a rate of 2.5 gallons per minute. So how big is our bathtub? It's 20 gallons. And we are draining the bathtub. That means the water is going out of the bathtub at a rate of 2.5 gallons per minute. So let's write that rate. We talked all about rates in chapter 1. So 20 gallons, and we are losing 2.5 gallons every minute. So how long is it going to take us to empty the bathtub? Well, let's think about this. If we're losing 2.5 gallons every minute, wouldn't it make more sense to say that we're losing 5 gallons every 2 minutes? Then we don't have the decimal to deal with any longer. So the number g of gallons remaining is a function of the number of minutes. Remember we talked about in the previous video that time is almost always an independent variable. So we're going to make a graph here of this function. So here's my x-axis, here's my y-axis, and anytime that we make a graph, we need to label our graph appropriately. So our graph is representing a bathtub draining. And then our x-axis is going to be our time. Our time is going to be in minutes. And our y-axis is going to be gallons remaining. Why remaining? Because we're draining the bathtub. So now, let's think about an appropriate scale. So first of all, we have a 20-gallon bathtub. So let's put 0 at the bottom and 20 at the top, and then cordon it off from there. So here's 10, here's 15, here is 5, and then everything in between. Now what did we say? We said we're losing 5 gallons every 2 minutes. So if we're losing 5 gallons every 2 minutes, I think our our x-axis, this is x, this is y, it should be in increments of 2. 2, 4, 6, 8, 10, 12, 14. So from here, we are going to be able to graph the draining of the bathtub with the 20-gallon bathtub losing 5 gallons every 2 minutes. So where do we start? Well, at 0 minutes, the bathtub has 20 gallons in it. Now, the next thing we need to think about here, is this graph going to be continuous or discrete? So think about this. The bathtub is draining. Think about draining. Picture pouring water out of a bathtub or out of a gallon milk jug. Well, if that's happening, that is a continuous flow of water. So this is going to be a continuous graph. This is going to be a continuous graph where we start at 20 and then after 2 minutes, 5 gallons have left. So after 2 minutes, 20 minus 5 is 15. So basically the water is draining continuously out of the bathtub. 2 more minutes later, 5 gallons less, that's going to be 10. 2 more minutes later, another 5 gallons are gone. 10 minus 5 is 5. And now we have 5 gallons, and after 2 minutes, another 5 gallons are gone, which means after 8 minutes, the bathtub will be completely empty. So, discrete in the previous graph, continuous in this graph. So, continuous, draining at a rate of so many gallons per minute. All of these words are lending to whether or not we're talking about continuous or discrete. Let's do one more problem. You're packing books into boxes. The function y equals 20x represents the number y of books that will fit into x number of boxes. So if y equals 20x, And we are saying that y equals the total number of books, and those books are going into X number of boxes. So first of all, are we going to chop a book in half? No. Are we going to pack half a book or a third of a book? No. This is going to be a discrete function. So we've got two questions here, but first, let's think about a table of values for just a moment. So X is our number of boxes and Y is our total number of books. Now, if our function is Y equals 20X, if we have 0 boxes, 20 times 0 is 0 books. Obviously, if we have 0 boxes, we have 0 books. So the number of books is dependent upon the number of boxes. That makes boxes independent, and it makes the number of books the dependent variable. So let's look again. If we have 1 box, 1 times 20 is 20. This is telling us how many books per box. 20 books in every box. And obviously we can keep going here. 2 boxes, 40, 3 boxes, 60. Let's look at A. Is 4 in the domain? Well, remember, domain, you learned this in pre-algebra, has everything to do with a dependent variable. So could we keep going here with our chart? Of course we could. Could we have 4 boxes? Of course. That would give us 80 books. So is 4 in the domain? Yes, 4 is a plausible domain value. The next thing it says, is 60 in the range? The range are the y values. So is 60 in the range? Yes, it is. Why is 60 in the range? Because 60 is a multiple of 20, and the boxes are coming in increments of 20. So this is a discrete function. 4 is in the domain, yes, because 4 is the number of boxes. 60 is in the range. 60 is in the range because it is a multiple of 20. This is a discrete function.